This video is going to be a few problems from your stoichiometry notes. First one I'm going to do is number 2 on your notes. I'll do number 2, 3, and 6. 2, 3, and 6 on here. Each one's a little bit different problem. So first one is a moles to moles problem. So you're starting off with 7.2 moles of hydrogen. Okay, so we got 7.2 moles of that. And it's working to moles of NH3. Okay, it could have asked you how much nitrogen was used with this, but it's saying if you use that much hydrogen, how much NH3 was produced in this reaction. So we always start with what they give us, so 7.2 moles of H2. If we start with moles, our next step will always be our ratio. So our ratio here is for every 3 moles of H2 that are used in the reaction, there's 2 moles of NH3 produced. So the ratio always gets us from one thing in the equation to the other. So we're just using the little numbers out front, 3 moles to 2 moles. This one's obviously smaller moles, so our answer should be less than 7.2. So for every 3 moles of H2 that are used in the reaction, there's 2 moles of NH3 that are produced. Okay, so this is just a mole-to-mole problem, so these moles cancel. Make sure your labels cancel. You're multiplying across the top, dividing by the bottom, and you get 4.8 moles. So if you would use 7.2 moles in this reaction, you'd produce 4.8 moles of NH3. It's the same ratio as 3 to 2, which is 7.2 to 4.8 in this case. Second one down here, number 3 down here, is giving us moles of water. So it's telling us the moles of water, and we're going to grams of glucose. It wants to know how many grams of glucose can be made from a certain number of moles of water. So same pretty much steps. We're going to start with our 3.65 moles of water. Again, we're starting with moles, so we know we need moles of water down here. The labels always have to cancel. We're going to our ratio. So for every 6 moles of water that we use in this reaction, there's 1 mole of glucose produced. Again, this problem just happened to ask us about glucose. It could have asked us about carbon dioxide or oxygen. If that was the case, those would both be in a 6-to-6 ratio. But glucose is a 1-to-6 ratio here. It's 1/6 of what water is. Moles cancel. So if we stop right now, we're at moles of glucose. But the problem asked us for grams of glucose. So we need to turn moles of glucose into grams. This is moles of glucose, so put moles of glucose down here. And we're going to add up what a mole of glucose is off the periodic table. So you got 6 carbons, 12 hydrogens, and 6 oxygens. If you add those up, it's 180 grams. So a mole of glucose has a mass of 180 grams. Taking 3.65, dividing it by 6, multiplying by 180. So it's that many grams of glucose that would be produced. If you start with this much water, that's the max amount of glucose that can be made in this reaction from that much water. So that was a moles to grams problems. Notice we still do the ratio in there. We always do the ratio to get from one thing to the other. We never skip that step, no matter what. I'll do one more problem that is grams to grams. It'll be number 6. Let me move this so we can see it just a little bit better. So this question is going to be a grams to grams problem. Again, it's number 6 in your notes. It's saying if you have 125 grams of oxygen produced, so it's starting with grams of oxygen. It's giving us 125 grams of oxygen, so we're going to start with that. Notice oxygen is O2. It's diatomic, so it's grams of O2. It's not just grams of O. So it'll have a different mass per mole. and it wants to know how many grams of that would we have had to start this reaction off with to produce 125 grams of oxygen. So starting with grams, we're going to turn this into moles of oxygen using the periodic table. Do our ratio, which is going to be a 1 out in front of there to a 2 there, and then turn it into grams of this. So these grams into moles, ratio, turn this back into grams. Grams of oxygen down here, it's 32 grams per mole of oxygen, so that cancels. So that's how many, if we divide those two, that's how many moles of oxygen we have. Do our ratio. Oxygen's on top, so oxygen comes down here, and it is a 1, so it's for every 1 mole of oxygen that's produced in the reaction, we used 2 moles of HGO. So this cancels. Now we need to turn this into moles. Okay, when I'm doing this, I just do the mass of 1 mole of mercury oxide. Okay, so if you're going to put a 2 down here, because there's a 2 right there, that means you have to double your mass up top. So the only time I use those coefficients is in the mole ratio step. So a mole of mercury oxide, 16 plus 201 is 217 grams. We know we're done when we get to grams. 125 divide by 32, multiply by 2, multiply by 217. Our answer is that many grams HGO. Good luck.